Let's talk about angle of elevation and depression. But before we solve any problem, there's a simple idea I want you to know. The idea of angle of elevation and angle of depression. Say we have an observer, the line of sight where you would most likely naturally look to, and you have an object here. This is the object. If the observer is observing an object above the line of sight, we call this angle the angle of elevation. But if the observer is observing an object below, we call this angle the angle of depression. Let's jump into question solving. Our first problem is a woman is standing on the ground at a point 20 meters from the base of a building. The angle of elevation to the top of the building is 57 degrees. How tall is the building? Solution. If you are solving angle of elevation and depression problem, it is important to draw out the diagram. Let's say this is where the woman is standing and this is the building. This is the ground. Our question tells us that our woman stands at this point 20 meters from the base of a building. That means from this point to the bottom of the building is 20 meters. The angle of elevation to the top of the building is 57 degrees. That means from this point, her line of sight to the top of the building, the angle that she's using to observe the top of the building is 57 degrees. And then we are told to find how tall the building is, so which is the height of the building. From here, once we found this out, the next thing we can do is to use a tool called SOHCAHTOA. How do we know whether to use sine or cos or tan? We look at the angle we are given and the sides that we are given. The angle we are given is 57 degrees and then the opposite side is h. If this is the opposite side of the angle, this is the adjacent side. Then the side opposite the 90-degree angle, this is assumed to be 90 degrees, is called the hypotenuse. Since we are only given the opposite and the adjacent, we compare it with what we have in the SOHCAHTOA. O here in the SOHCAHTOA simply means opposites, while H means hypotenuse and A means adjacent. Since the two things we care about is the opposite and adjacent, we look for the ones that contain opposites and adjacent. Now this one is the one that contains opposites and adjacent, the TOA. That means this is tan theta is equal to opposite over adjacent. Theta is 57 degrees. Adjacent is 20 meters. And hypotenuse is what we don't know. Then we can say tan theta, tan 57 degrees is equal to h over 20. We can cross multiply from here and say h is equal to tan 57 times 20. If you use your calculator, tan 57 degrees times 20 is 30.80 to 1 decimal place. The height of the building is 30.8 meters. Always remember to write the units when you finish solving. Let's look at another question. For question 2, we are told that Matt is standing on top of a cliff 20 meters above a lake. The measurement of the angle of depression of a boat on the lake is 42 degrees. How far is the boat from the base of the cliff? Let's write our solution. Remember, our first step is to draw out our diagram. Let's assume that this is the cliff that Martin is standing on, cliff, and Matt is standing on the cliff. He observes a boat on a trail. Let's say this is the location of the boat, and This is on a stream, of course. So you observe these boats at an angle of depression of 42 degrees. Remember, this is the lines of Martin's sight. This is his line of sight. So the angle of depression is this angle, 42 degrees. This angle is 42 degrees, then this angle is 42 degrees. Because this is a right angle triangle and this line of sight is assumed to be parallel to this line. This is 42 degrees, this is 42 degrees. We are told that the height of the cliff is 20 meters. And we are told to find how far is the boat from the base of the cliff. So that means we are told to find this distance, the base of the cliff. So the boat, let's call it distance D. Normally, the next thing to do at this point is write out what you know. Now we are given the opposite and the adjacent side because we know that this is the hypotenuse. Now from our SOHCAHTOA, the side that relates these two sides is tan theta. So tan theta is equal to opposite over adjacent, where our theta itself is 42 degrees. So our opposite is 20 meters. And our adjacent is D, which is what we are looking for. From here we can see tan 42 is equal to 20 over D. We cross multiply from here so that D is equal to 20 over tan 42, which is equal to 20 over tan 42 from our calculator is 0.9004 to 4 decimal places. If you divide 20 by 0.9004, you get equals to 22.21 to 2 decimal place. Now, if you're having problem with understanding what 2 decimal places is or 1 decimal places are, I'll leave a link here so that you can go watch a video where I talk about approximations. So this means that the distance is equal to 22.21 meters. So the distance from here to here is 22.21 meters. Let's take another example. Or a third example, you can pause the video and try to solve this one yourself. Like we've been doing before, we write a solution and we draw a diagram of what is happening. We are told that an observer on a cliff 1,000 meters above sea level sights 2 ships due east. The angles of depression of the ships are 47 degrees and 37 degrees. Find the distance between the ships. Let's assume that the cliff we are dealing with is this cliff. This is the cliff and an observer stays here. The observer is able to observe 2 ships. Let's say this is ship A, and another ship B. The first ship the observer observes, and the second ship the observer can observe this way. This means that they have a connecting line between, since both of them are on sea level, they have a connecting line. This means that ship A is observed at an angle of 47 degrees, and then ship B is observed at an angle of 37 degrees. We are asked to find the distance between ship A and ship B. Let's call this distance AB. Let's call the bottom of the cliff C. We know that the height of the cliff is 1,000 meters. From here, like I said before, if you have an angle like this, because this is supposedly parallel to this side, this angle is 37, this angle is also 37. If this angle is 47, this angle is also 47. We can draw all of this out so that we don't get confused. I'll draw it here on a bigger space without all the extras. This would be 8, and this is angle 37 degrees. This is a 47 degrees angle, and this is the height of the cliff, which is 1,000 meters. Now I label this as A, and I label this as B, and I label this as C. We are told to find the distance between 2 ships, which means that we have to find AB. So we have to find line AB. How do we do this? How do we find AB? We can decide to find this line from here to here and find from here to here. Then if we have from here to here and here to here, if we subtract them, it should give us the value of here to here, which is what we are looking for. So first find CB. All right, CB for line CB. Fancy notation here just means that we're looking for line CB. The triangle concerned with line CB is this triangle BC. This is 37 degrees and this is the 1000 meters. The trigonometric function connecting these two parts is tan. We know that tan theta is equal to opposite of adjacent. So from here we have our theta to be 37 degrees. Our opposite here is equal to 1000 meters. Our adjacent is line CB. Let me clean up space so that I can do it here. That means we have tan 37 is equal to 1000 over CB, line CB. If I cross multiply, I have line CB is equal to 1000 divided by tan 37. 1000, this is equal to 1000. We have tan 37 as 1037 is 0.7536 to 4 decimal places. If we do that, you have line CB to be equal to 1327.04 meters. Now that we found line CB, we can go ahead and find the triangle we are looking at is this triangle. Because of lack of space, I'm going to clean this out and redraw this one again. Since we know that CB is equal to 1327.04 meters. Next thing is to find the line CA. So how do you find line CA? The triangle we are considering for side line CA here is this triangle. I can draw it out as this. This is 47 degrees and this is 1000 meters. This is CA. How do we find CA? So this is for CA. This is triangle under consideration. How do we find CA? The same relationship. So we have tan theta is equal to opposite over adjacent, where our opposite is giving us 1000. Our adjacent is equal to CA and our theta is 47 degrees, so that we can say tan of 47 degrees is equal to 1000 over CA, line CA. If you cross multiply from here, line CA is equal to 1000 divided by tan 47. This is then equal to 1000 divided by tan 47 is 1.07234, 4 decimal places. If we do the math, that means line CA is equal to 932.54 meters to 2 decimal places. Now that we have line CA and line CB, we can find line AB. So that line AB is equal to line CB minus line CA. So from there, we know that we have to subtract this. We have to subtract this from this. That means that we have 1327.04 minus 932.54. This is equal to 394.5 meters. This implies that the distance between the two ships is 394.5 meters. Let's take another example. For our next example, we have, let's make solution first. We are told that a tree is struck by lightning and snaps off 34 meters above the ground. The top part of the tree 117 meters long rests with the tip on the ground whole, and the broken end rests on top of the stump. What angle does top part of the tree make with the ground? So this is something that you can draw out. We know that we have a tree as first, and then the tree was struck by lightning. So what happened was that the tree broke, and then we had two parts, top parts and the bottom parts. So this is supposedly the ground. We are told that from the bottom to where it was struck by lightning is 34 meters. And the top part of the tree that broke off is 117 meters. They now told us to find the angle that the top part of the tree makes with the ground. So this is supposed top part of the tree that fell on the ground. So we are told to find this angle theta. Let's draw a triangle without all these extras. If we draw a triangle without all these extras, we have a triangle that looks like this. This is theta. This is 117 meters. This is 34 meters. Now, if you look at what we're given here, the angle that we're given is theta. So we're giving theta as theta. And we're also giving the opposite side of theta. This is the opposite. The opposite is 34 meters. And we're giving the hypotenuse as 117 meters. Remember the abbreviation that we use to get the sign that we use. So this is SOHCAHTOA. We add opposites and hypotenuse. So the one combining opposite and hypotenuse is sine. This is the opposite and this is the hypotenuse. We are going to use sine in this case. That means we have sine theta is equal to opposite hypotenuse. We are already plugging our values now. We know that sine of theta still there. We're not giving it theta. Opposite is 34. Hypotenuse is 117. From here we can directly solve and say sine theta is equal to 34 divided by 117, 0.2906. So 4 decimal places. How do we get the value of theta? You can get the value of theta by doing the sine inverse. So this is equal to move the sign to the other side, we have sine inverse of 0.2909. If you check your calculator, you should see a sine inverse sign. Or if you press shift of sign, you should be able to do your sine inverse. So if we have to find sine inverse of this number, we have the sine inverse of this number is 16.89 degrees. Always remember that theta is not measured in length, it is measured in degrees. In most questions, you're going to give the answer in degrees. Let's look at our last example. For the last example, let's say we have a 75-meter rope is attached to the top of a 50-meter building. If you are laying on the ground where the rope reaches and you're looking to the point where the rope is attached to the building, what is the angle of elevation? Let's say this is you on the ground and this is the building. This is 50 meters. The building's height is 50 meters from the ground and both of you are at the same level. This is the base of the building. This is you. We are told that a 75-meter rope is attached from the top of the building. That means from this point where you're staying to top of the building. And then we are told that the total length of the rope is 75 meters. We are now told to find the angle of elevation. Remember, the angle of elevation is the angle above line of sight. This is your line of sight. So this is the angle we are looking for, theta. From our SOHCAHTOA, if this is theta, this is opposite. So our given is opposites is equal to 50 meters. We are not giving the adjacent, but we are giving the hypotenuse. Our hypotenuse is equal to 75 meters. Then for our theta, we do not know. Our theta is our angle of elevation, and that's what we are looking for. The trigonometric term that relates these two things is the sine from the SOHCAHTOA. This is sine. Theta is equal to opposites over hypotenuse. We are now ready to cross multiply, and we have sine theta is equal to 50 over 75. We know that sine theta is equal to 50 over 75 is 0.6667 to 4 decimal places. How do we get theta? Theta is equal to a sine inverse of 0.6667, and then theta is equal to sine inverse of 0.6667 is 41.81 degrees. This implies that the angle of elevation we're looking for is 41.81 degrees. So that's how to solve problems on the angle of elevation and depression. If you like this video, leave a thumbs up, share with your friends that will find it helpful, subscribe to the channel, it's also helpful, and I'll be releasing content more regularly. Thanks for watching.